This video is going to be all about mole and mole conversions. So to start, we're going to look at what is a mole. So a mole is this number of really anything, but typically in chemistry, atoms, particles, molecules, etc. A mole is similar to a dozen. So if I said I had 1 dozen carbon atoms, I would mean that I have 12. If I said that I had a mole of carbon atoms, I would mean that I had 6.02 times 10 to the 23rd. And this is a very massive number. You can see here that it's going to be 23 places. So I'm going to have to add 21 zeros here. This number is necessary though, because when we're talking about things as small as atoms and particles, we need a number that makes it more compact to discuss and put in numbers that can be a little more logically understood. If we always had to talk about things operating at this giant number, it would make a lot of calculations and stuff more convoluted and less easy to interpret. So for us, knowing that this is going to be equal to 1 mole will help us do reactions and figure out a general ratio when things are being produced and many other applications. In order to convert the mole, we have something that is known as the mole map. And that is to say that we have 3 main categories that convert to mole. The first one is amount. And amount is going to refer to atoms, particles, molecules, really anything you can count. Some other words we might see are formula units or representative particles. As I stated, you can really count a mole of anything. You can count a mole of pennies, a mole of donuts, whatever it may be. It just represents a very specific value of something. The important thing here is that the conversion we're going to use is between mole and amount. And the factor we'll use is that 1 mole is equal to 6.02 times 10 to the 23rd of any of kind of those words that I just listed. So the labels on these are kind of variable. It depends what we're talking about or what we're counting in this case. So when you see a problem and you see a word like atom or particle or molecule, it is referring to this amount conversion. So if we go to our practice problems here, as always, we'll start off with what we're given. So the first thing here is 4.13 moles of helium. And we're trying to figure out how many atoms of helium there are. So we want to use that conversion factor. We want to be able to cancel out the unit that we have. So mole will go on the bottom, and it'll be 1 in this case. And we, as we discussed, 6.02 times 10 to the 23rd. For this specific problem, we have atoms. And then we can simply multiply those 2 terms on the top. We went around to sig figs, 3 sig figs based on this number here. And we should find 2.47 times 10 to the 24th. And if we cancel out the mole unit, that would be atoms. The next problem, we're starting with a counting number. In this case, the label is particles, but again, this is an amount. So the label can change. Now, in this case, we want to be dividing by this number, which is also known as Avogadro's number. Be very careful when plugging this specific version of the problem into your calculator, because oftentimes students, if they don't enter it correctly, will end up actually multiplying by this part of that number and get a very crazy exponent like 48, 49. And so if you divide it correctly, you may need to use parentheses. You should, to the correct sig figs here, get 160 moles. So if you get 1.6 times 10 to the, like I said, 48th, 49th, that probably means you did not enter it in your calculator correctly. Now, the second term that we will be converting with is going to be volume. Now, this is specifically volume of a gas. And the important thing here is that this is contained at STP, and you kind of see a little bit from that picture. But STP stands for standard temperature and pressure. So standard temperature is going to be 273 Kelvin, and standard pressure is going to be 1 atmosphere. Because gases are able to compress, the conversion that we will see only applies when these STP conditions are met. Otherwise, you would have to adjust for changes in how the atmosphere or the temperature might expand or contract the gas. This conversion factor is going to be 22.4 liters. And that means that there's 22.4 liters of gas at STP for 1 mole of gas. So if we look here at our example problems, we start with 4.9 liters of water vapor. And like always, we'll want to cancel our unit. 22.4 will always go with liters when we're doing these conversions, and 1 will go with mole. The abbreviation for mole is MOL. If you want to put the extra E, you can. Multiplying this by 1 and dividing by 22.4, we're going to get 0.22 moles. Setting up our second one, 13.9 moles. Moles at this time will need to go at the bottom so we can cancel it. And 13.9, I lied, 22.4 is what we'll want to put at the top for our conversion, since we are trying to end up and convert into liters. Multiply and round to 3 sig figs, and we get 311 liters. The last and maybe more familiar conversion we have is going to be to mass. And this one is going to involve the periodic table. So 1 mole is going to equal molar mass, or mass in grams, based on the periodic table. Now, if you notice, this is going to be the only one that does not have a constant. So we see that this conversion factor here, go back here, this conversion factor here is always the same number. This conversion factor here is always the same number. However, this number will change based on what the substance is. The other two, the substance does not matter. It will always be that same value. However, in mass conversions, we will need to pay attention to what atom or molecule or formula unit that we are using. So we see here for this problem, we'll start with our 64 grams. And we have oxygen gas. Now, oxygen gas is O2 because of Oberfinkel. So that, if we look up, is 16 on the periodic table, meaning 32 grams is equal to 1 mole. Dividing it by 32, 1 mole on top, so we can cancel out grams. And we'll see that this is 2, and we want 2 sig figs, 2.0 mole. For the next one, we're starting with 0.75 moles. And in this case, we have potassium metal. So we'll put 1 mole on the bottom to cancel out mole. We look up what potassium metal is, and we see it's 39.1 grams on the periodic table. Again, this is representing its molar mass, or how many grams 1 mole of it would weigh. When we multiply across to get our answer and round it, we should get 29 grams, which should make sense because 29 should be about 75% of 39. Then next, we'll try some multi-step problems. It's important to note that when we're converting, mole is kind of a pit stop because we have a conversion from everything to mole. So in this problem, when we have grams and liters, we have to stop at mole in between. 5.0 liters. We can convert, we know, liters to moles. But then we can keep going because now we know we can also convert moles to grams. So 1 mole will go on the bottom. Again, kind of just being an intermediary step. And water vapor is H2O. Oxygen is 16. Water has 1 of them. And then H is 1.01 with 2. So this means 18.02 is our molar mass for water. And we can divide 5 by 22.4 and then multiply it by 18.02. And after rounding, get that there would be 4 grams of water vapor if we had 5 liters of it. Similarly, if we instead wanted to find out how many atoms, or I guess molecules would be a better term here, of water vapor there was, we would start the same way, but then instead we can go and convert it to our molecule number. So the last step will change based on the information we're looking for. Again, trying to round to sig figs, we get 1.3 times 10 to the 23rd.